You've looked up at the moon your entire life. One moon, one orbit, one companion circling Earth since long before humans existed. Simple, settled, understood. But in August 2025, astronomers in Hawaii pointed a telescope at the sky and found something that changed that picture entirely. A startling discovery. A rock, roughly the size of a building, had been traveling alongside Earth for 60 years. Not approaching, not passing through, traveling with us, looping around our planet in the dark, unseen since the 1960s. And it was not alone. Earth, it turns out, has been hiding an entire entourage of shadow companions, quasi-moons, mini-moons, objects drifting in and out of our gravitational neighborhood that no one knew existed. Some of them may be pieces of our own moon, blasted into space by impacts so violent they reshaped the lunar surface millions of years ago. Fragments of a cosmic crime scene still circling the evidence. In this video, we're going to uncover what these hidden companions are, where they came from, and why the answer is forcing scientists to rethink everything they assumed about Earth's place in the solar system. Here's what we thought we knew. Earth has one natural satellite, the Moon. Everything else in our orbital neighborhood, like asteroids, comets, and space debris, is just passing through, cataloged, tracked, understood. We were wrong. On August 2nd, 2025, the Pan-STARRS Observatory on Haleakala in Hawaii detected a faint object designated 2025 PN7. It was small, between 15 and 30 meters across, roughly the height of a 10-story building, but its orbit was strange. It was not crossing Earth's path like a typical near-Earth asteroid. It was matching it, following the same route around the Sun at almost exactly the same speed, looping around Earth in what astronomers call a quasi-satellite orbit. Carlos de la Fuente, Marcos, at the Complutense University of Madrid, ran the numbers and found something unsettling. This was not a new arrival. 2025 PN7 had been in this orbit for approximately 60 years, since the 1960s, since before the moon landings, before Voyager, before we even had the technology to notice it. And when researchers checked archived images, they found it had been captured on camera as far back as 2014. We had been looking right at it. We just did not know what we were seeing. What makes this worse is that 2025 PN7 is not an anomaly. It is the newest addition to a growing list. Astronomers have now confirmed 7 quasi-moons orbiting near Earth, and over 100 Arjuna-class asteroids, small rocks that share our orbital path around the Sun. Earth is not traveling alone through space. It never was. We just could not see the crowd. But the real question is not how many companions Earth has been hiding. It is where some of them came from. For decades, the assumption was straightforward. Near Earth, asteroids come from the asteroid belt between Mars and Jupiter. They get nudged by gravitational interactions, drift inward, and occasionally cross our path. Foreign visitors from deep space. This assumption started to crumble in 2021. A team led by Ben Sharkey at the University of Arizona turned the Large Binocular Telescope toward Kamo-O'Alewa, a quasi-moon discovered in 2016. Kamo-O'Alewa is about the size of a Ferris wheel, from 40 to 100 meters across, and it spins once every 28 minutes. When Sharkey analyzed its reflected light, he found something no one expected. The spectrum did not match any known asteroid. It matched lunar rocks. Specifically, it matched silicate samples brought back by NASA's Apollo missions. As Renu Malhotra, a planetary sciences professor at the University of Arizona, noted, it is very unlikely that a typical near-Earth asteroid would spontaneously move into a quasi-satellite orbit like Kamo-O'Alewa's. Something else was going on. In 2024, a study published in Nature Astronomy traced Kamo-O'Alewa's origin to a specific location, the Giordano Bruno crater on the far side of the Moon. The crater is nearly 14 miles wide, carved by an asteroid roughly a mile across, sometime in the last 1 to 10 million years. The impact was violent enough to blast intact fragments off the lunar surface and into orbits around the Sun. Kamo-O'Alewa is one of those fragments, a piece of our own moon, wandering through space for millions of years. and it gets worse. In January 2025, researchers led by Teddy Kurita at Lowell Observatory published findings in the Astrophysical Journal Letters showing that 2024 PT5, the bus-sized asteroid that temporarily orbited Earth for 2 months in late 2024, also has a spectrum rich in lunar silicates. A pattern is emerging. Earth is not just collecting random space debris, it is being orbited by pieces of its own moon. Until now, we've studied the moon by going to the moon. We've studied asteroids by going to asteroids. These were separate categories, separate missions, separate questions. That distinction is about to disappear. On May 28, 2025, China launched Tianwen-2 from the Xichang Satellite Launch Center on a Long March 3B rocket. Its destination is Kamo-Oalewa. The spacecraft will reach the asteroid in July 2026 and attempt something unprecedented, collecting surface samples from what may be a fragment of our own moon drifting through space millions of kilometers from where it was born. The mission carries 2 sampling systems. One is a touch-and-go mechanism, similar to the ones used by NASA's OSIRIS-REx and Japan's Hayabusa 2. The other is a never-before-tested anchor and attach system with 4 robotic arms, each equipped with a drill, designed to latch onto a body with near-zero gravity that spins once every 28 minutes. If it works, Tianwen-2 will collect roughly 100 grams of material and send it back to Earth in a re-entry capsule traveling at 12.1 kilometers per second, faster than any lunar return. And if those samples confirm what the spectral data suggests, Kamo-Oalewa will become the first near-Earth asteroid ever traced to a specific crater on another world. But this is only the beginning. Scientists estimate the Giordano Bruno impact alone produced tens to hundreds of 10-meter fragments. Most fell back to Earth as lunar meteorites. A few survived in orbits around the Sun. Eric Asfog at the University of Arizona called Kamo-Oalewa a kind of missing link, connecting lunar samples collected by astronauts on the surface with meteorites that fell to Earth. The upcoming Vera Rubin Observatory and NASA's NEO Surveyor are expected to find more of these hidden lunar fragments, potentially redefining our entire catalog of near-Earth objects. The boundary between moon and asteroid is dissolving. The solar system we thought we mapped is revealing itself to be far stranger and far more connected than anyone imagined. So here is where we are. For 60 years, a rock the size of a building traveled alongside Earth, and no one noticed. For millions of years, fragments of our own moon have been drifting through the space we call home, disguised as ordinary asteroids. A spacecraft is now flying toward one of them to bring a piece of it back. We spent centuries staring up at the moon, mapping its craters, naming its seas, walking on its surface, and the whole time, pieces of it were out there, circling us, hiding in our blind spots, waiting to be found. That is the thing about the solar system. It was never the tidy diagram in a textbook. It is violent, restless, constantly reshuffling itself. Rocks get blasted off moons. Asteroids drift into orbits that mimic companionship. Gravity bends trajectories that will not repeat for centuries. And we are only now building the instrument sharp enough to see it. Every quasi-moon we discover, every lunar fragment we identify, is a reminder that the universe has been doing things around us that we had no idea were happening. The moon did not just give us tides and eclipses, it gave us pieces of itself. And we are only now learning to find them. If you found this as fascinating as I did, please subscribe. I'll see you next time.